Guys, this is the problem that we wrestling with in this question here, question number 2. This can be an SAT test or can also just be a regular test, in the classroom, all right? So if a squared plus b squared equals to r and a plus b equals to 8, what is the value of 5r plus 10s given that a times b equals to s, okay? So this is s, this is s, this is not 5, okay? All right, and then we have 5 possible answers. A, 50, B, 19, C, 88, D, 320, E, 160. So let's see which one is the correct answer. Again, ladies and gentlemen, there's only one correct answer. So what do we know? We know that a squared plus b squared equals to r. And then we also know that a plus b is 8. We know 5 times r plus 10s, and then we know a, b equals to s. So if we know this one, where we have r and s, we can take them and then plug it in here, right? Substitute in here, replace in here. So what does that mean? That means we're doing 5r, right? So what is r? R is, so that means times a squared plus b squared plus 10 times s, and s is what? AB times a times b. Are you with me so far? We're getting somewhere, right? So we're taking this one, and then we have this. So can we just work it out? Yes, of course. So this is going to give us what? 5 times a squared plus 5 times b squared, all right, plus 10 times ab. So this is looking like something, a polynomial that we should know about already, right? But how can we put it so that it can be the exact one? So we have 5a squared plus 10ab, so I'm taking the 10ab, put in the middle, plus 5b squared. All right? So this is looking like something that we already know about. But what else can we do? We have something in common for all these, these terms here. What is it? 5. So we can take 5 out. So if we take 5 out, so it's going to be 5 outside a squared plus 2ab plus b squared, right? Because once you divide each of them by 5, so you end up with a squared for the first one, plus 2ab for the second one, plus b squared for the third one. So what does it look like? Okay, the perfect square here. Okay, so this one looks like a perfect square in this case. So the sum of that one, so what would that give us? So when we know it, that is a perfect square, so that means what? That means if you take the square root of a squared, that is a. You take the square root of b, that gives you b. And then if you, multiply by 2, so that will give you 2 times ab. All right? So this one is giving us what? A plus b squared. Okay, so that's what we call the perfect square, right? Because again, if you take the square root of a squared is a, square root of b squared is b, and then when you multiply them by 2, the a and the b by 2, you get 2ab in the middle. And that's how you recognize the perfect square, problem, okay? So then this is what we have, but we're not finished, because if you look at the answers, nothing like that is there. But is there anything that we know about a plus b? Yes, because a plus b equals to 8. So when we go further, so we have 5 times, so instead of having a plus b squared, so that means a plus b equals to 8, right? So if a plus b equals to 8, but don't forget about the square, because this one is squared. So the first thing we got to do is to multiply a by 8, which is 64, so it's 5 times 64. And 5 times 64 then is going to give us what? Okay, it's going to give us 320. Okay, because 5 times 4 is 20, so you keep the 2, and then 5 times 6 is 30. 30 plus 2 is 32, so that gives you 320. So we have 320. Do we have 320 here? 50, 1988, 320 is here. The fourth answer. So this one is correct. And then we are good. All right? So guys, you see problems like this. It's not difficult. but these are problems that you have to practice more and more so that once you see it, you automatically know where you're heading to. And then the trick part is when you get to this part, you have to understand that because all of them carry a common denominator, which is 5, so GCF is 5, greatest common factor, okay, which is 5, so you take that one out. And then you end up with a squared plus 2ab plus b squared, which is perfect square, okay? Perfect square problem, okay? So then you end up with a plus b to second power. Because if you take this problem, then you multiply by itself, you should get this back. Okay, that's how you can check it. All right, guys?